Okay, this is part one of the lesson on organic chemistry. Okay, so before I'm going to do some basic stuff here because people generally aren't very good at organic. So let's start from the start because I think it's important. Okay, so why organic chemistry? Organic chemistry, first of all, organic chemistry is the chemistry of carbon. Okay, of carbon compounds, I should say, I guess. Carbon compounds. Okay, now believe it or not, except there's two compounds that we don't deal with. Carbon dioxide is not organic, and the carbonate ion. Oh, it's weird, but these are exceptions. These aren't organic things. Okay, so why do we look at organic separately? Well, carbon forms literally millions of compounds. All right. So we have a separate part of chemistry for organic chemistry. All right. It's nothing to be scared about. It's just life, I guess. There's lots of things. So when we've got something so big, organic chemistry is enormous. Okay. The only way we can deal with something so big is to split it up into bits. Okay. On our course, we split it up into 4 bits. Okay, and these are the bits. This first one is called alkanes. The next one is alkenes. Next one is alcohols. And the last one is acids. Okay, now these 4 bits that we separate organic into, these are known as homologous series. Homologous, hard word, series. So there are 4 homologous series we study. There's loads more homologous series, but we only study 4 of them. Okay. Now, let's have a look. A very brief look. This is an overview of these homologous series. Alkanes. Okay. Now, these are hydrocarbons. That means they contain carbon and hydrogen only. Okay, so there's a good example of an alkane. Okay, so that's a hydrocarbon. Alkenes, well, they're also hydrocarbons, but they have a special bit in the middle there. Okay. Alcohols, they're not hydrocarbons. Alcohols contain oxygen. So there we go. There's an alcohol. Now, the trickiest one for us, on our course anyway, are the acids, because this has a hard part to draw, that bit at the end. Okay, so there you go. There's examples of the 4 homologous series. Let me get rid of those tiny dots. They're annoying me. All right, now, what are they called? What are these guys called? Well, I've purposely done it so there's 2 carbons in each. So this is F, this is F, this is F, and this is F. F means 2. Okay, if you've got 1 carbon, carbons, number of carbons, and name. If you have 1 carbon, 2 carbons, 3 carbons, 4 carbons, 5 carbons, that's all we've got to know about, really. If it's 1 carbon, it's meth. If it's 2 carbons, it's F. If it's 3 carbons, it's pro. If it's 4 carbons, it's bute. And if it's 5 carbons, it's pent. These are the only ones that we've got to know about. Okay, so these are all 2 carbons, so these are all F. Are we good so far? Am I going too slow? Am I going too basic for you guys? If I'm going too slow, please tell me. All right, but I want to start from the start. Are we good? Thumbs up, thumbs down. Thumbs up for Arona's good. Okay, cool. So now the first one is an alkane. So this gets the suffix. We say the suffix "ane." Suffix, this is the bit at the start of the name. This is the prefix. And the suffix, the end of the name, comes from whatever homologous series there are. Homologous series. Okay, so this first one is an alkane, so it's ethane. Next one is alkene, so we call it ethene. Next one is an alcohol, so we call this anol or ethanol. And this is ethanoic acid. Okay, so, whoops, that's not good, is it? But that's close enough. So there you go. So from the name, you can get the number of carbons and you can get the type of group it is, type of homology series. Now, as I've said before, these contain carbon and hydrogen only. Okay, and things that form carbon and hydrogen only or contain carbon and hydrogen only, these are known as hydrocarbons. Okay, these two are not hydrocarbons, the other two are not. Now, there's an interesting thing in organic chemistry called a functional group. Okay, so I'm going to write it down here. Functional group. Now, the functional group tells us how the thing is going to react. It's the gives the properties to the molecule. Interestingly, well, I think it's interesting, this first one, alkanes, we say alkanes have no functional group. All right, there's nothing there. It's just carbon and hydrogen. But alkenes, they do have a functional group. And the functional group of an alkene is that bit. So the functional group of an alkene is a carbon-carbon double bond. Functional group of an alcohol is the OH bit at the end. So this is the OH. And the functional group of a carboxylic acid is that bit at the end. So the functional group is the COOH. Okay, so these are the functional groups. So I think that's pretty well it for now. There you go, alkanes, alkenes, alcohols, ethanoic acids. We've done everything we need to do for now. So let's start with the first one. Now, I'm sure your wonderful teacher started off with alkanes. Okay, so she started off with alkanes. So let's have a look at some alkanes. Alkanes, as we say, oh, by the way, there's something I should mention here, and I forgot to because it's important. Okay, so let's get a nice color. That's this purple color. If it's got a double bond, it's called unsaturated, and if it hasn't got a double bond, it's called saturated. Okay, so alkanes are often known as saturated hydrocarbons. Okay, and that's an important thing. Saturated, this bit, means it contains only single bonds. This bit means the molecule is made of carbon and hydrogen only. That's a very important word, only. All right, so let's push this up a bit. Okay, and let's have a look at the first member of this. Well, the first member is something called methane. And there you go. I'm going to give the names of these in a minute. And then we've got ethane. Okay. The only way to get good at this, by the way, is you should draw them, eh? Then we have propane. Yeah, ethane, methane, propane. All right. There's the first three. Okay, and as you can see, what do I have to do? All you have to do, whoopsie daisy, wrong one. All you have to do is around the central carbon atom, or around any carbon atom, each carbon must have 4 bonds. So there you go. Each one has 4 bonds, and it's essential it's got 4 bonds. So there you go. So there's the first 3, and now the next one, bute, 1, 2, 3, 4. Okay. Now, as you can see, there's 2 ways I can draw this thing. Okay, I can draw. Oops. Larona's here. Hey, Larona, turn off your microphone, darling. All right. And there you go. So we got 4 in a row. So that's one way I can draw it. But I don't know if you know this, and if you're good at art, and I'm sure you're better at art than I am, you should realize you can draw this in another way. And you can draw this like this as well. Okay, there you go. So we can draw it 2 ways. And they both exist. Trust me, they both exist. All right, so there you go. There's 2 ways of drawing this one. So let's give them names now. Well, the first one's 1, so this is meth. Second one's 2, so this is eth. Third one's 3, so this is prop. Kyra's here now, good. This is prop. Fourth one is buttes, and this is also buttes. Okay, so there's 2 different ones there, aren't there? All right, now they're all alkanes, so we're going to give them a name now. Let's give it a different color for the second bit. Let's go for green. It's a nice color. So this one's called methane. This one is ethane. This is propane. Now this first one is butane, and the next one is also a type of butane, but we actually don't call this one butane. But it's a type of butane because it's got 4. Now there's a thing here that I'm sure you're aware of, but these 2, they're both got the same number of carbons, so they have the same number of carbons and the same number of hydrogens. Okay, but as you can see, they've got different structures. Now, does anyone want to tell me what we call that phenomena when you have the same number of carbons, same number of hydrogens, but you're in different structures? Do you know what that's called? If you don't say it quickly, I'm going to write it down. I'm just going to pick a nice color. No one? Okay, don't worry. If that is the case, we call these isomers. It's an R. So we say there are 2 isomers of butane. 2 isomers of butane. In other words, there's 2 ways we can draw them. Okay, 2 isomers of butane. Now the top one's called butane. Now the bottom one isn't called butane, but it is an isomer of butane. This bottom one, and I'm not going to go on crazy on names. Okay, but this one is called methyl propane. Okay, and the reason it's called methyl propane is, if you look at it, well, there's a methyl group, which is a CH3, on, let me try a different color, on a propane. It looks like there's a methane on a propane, so we call it methyl propane. Simple as that. All right, but it's an isomer of butane. Now, the next thing, what are the molecular formula of these guys? These, by the way, what I've drawn here are called structural formula. These are known as structural formula. And they're nice, and they tell us what the shape is. There's another formula I'll tell you about in a minute, but we don't have to worry about that too much. But this methane is CH4. This is called the molecular formula. Okay. And this one is C2H6. This is C3H8. This is C4H10. And this is also C4H10, isn't it? Because they have the same formula. All right. Now, as you can see, going from one to the next, and then from there to there, each time we add the same thing. Believe it or not, they change. All we're changing is we're adding a CH2, we're adding a CH2, and we're adding a CH2. So they go up by the same thing at each one. All you do to get to the next one is you add a CH2 unit. Okay, there you go. That's what forms a homologous series, by the way. They're separated from each other by a CH2 unit. All right. Now, believe it or not, we can have a general formula. So what I've drawn here is structural formula, but we can have a general formula to help us. Okay. Now, a general formula, all a general formula does is if you put in the number of carbons, you can find out the number of hydrogens. And the general formula for alkanes is this: CnH2n plus 2. And that, I'm afraid, you do have to learn. What's a nice color there? Green. So CnH2n plus 2, you got to learn. All right. So let's pick, what would the formula of decane be? What's decane? What's the formula of decane? Well, dec is 10. Okay, so it's C10. H2n, 2 times 10 is 20, plus 2 is 22. So the formula of decane will be C10H22. Okay, what's the formula? Last one, we'll do one more. If we've got C30, well, C30 is going to be 2 times 30 is 60, plus 2, 62. Simple as that. That's how we use the general formula CnH2n plus 2. Are we all good so far? Thumbs up, thumbs down while I'm moving up the page. Palace is good. Scope is good. Excellent. So that's you've got to draw these things. Well done, Arona. So we're all good. Okay, excellent stuff. So now, what are we going to do? So these are kind of the start of alkanes. And what do alkanes do? Alkanes. Now, these are the chemical formula. Sorry, the chemical properties. What do they do? Okay, well, the most important thing they do is they burn. Okay, and when they burn, they give off a lot of energy. Okay, and that's why we use these guys as fuels. Okay, they're the most important fuels. Now, if you've done geography, and I'm sure a lot of you have, this is the basis of what we call the petrochemical industry. All right, this is the petrochemical industry. In other words, the fuel industry. And we get all of these fuels from crude oil. Okay, which I don't think we'll talk about today, but you get them. All right, so they burn. That's all they do, really. Oh, they do one other thing, don't they? But they burn. Very simply, they burn. Simple as they burn. Okay, so let's pick one at random. Let's pick methane. CH4 plus O2 gives CO2 plus H2O. All right, so when they burn, they give carbon dioxide and water. Now I'm going to balance this. And this is how I balance. There's one carbon there, so there must be one carbon there. So that must be a 1. Must be. There's 4 hydrogens there, so there must be a 2 there, because 2 times 2 is 4. And then I jump over this side to the right-hand side. There's 2 times 1. There's 2 oxygens here, and there's 2 oxygens here. So 2 oxygens and 2 oxygens is 4 oxygens. So therefore, this must be a 2, and because 2 times 2 is 4. And that's the balanced equation for methane. Let me get rid of these funny things. We don't put a 1 in, do we? We get rid of this rubbish down here. We get rid of that and that. If I can squeeze that in, yeah, just about like that and that. So there you go. That's the equation for methane. Let's do another one. Let's do pentane. Okay, pentane, C5. H12. You see, 5 times 2 is 10, plus 2 is 12, plus O2 gives me carbon dioxide and water. Okay, let's balance this one. There's 5 of those, so there must be 5 of those. There's 12 of those, so there must be 6 of those. And then I go over the side. 2 times 5 is 10 oxygens. 6 times 1 is 6 oxygens. Total oxygens is 16. And therefore this number must be 8. And there you go. So that's how we balance these guys. Okay, I'm going to get rid of that. Okay, so there we go. Very simple. Well, it is to me. I don't know if it's to you, because I've been doing this a long time. Too long. All right. Now, when we burn these, the way you think of it is you fully oxidize. You fully oxidize the carbon, and when carbon is oxidized, you get carbon dioxide. And then you fully oxidize the hydrogen, and when you get fully oxidized hydrogen, you get water. So when you fully oxidize, you get always, when you burn an alkane, CO2, you always get carbon dioxide and water, because you oxidize both of them. Okay, someone's just dropped out. Larone is gone. It might be internet, actually. My internet was awful yesterday. Actually, I didn't have any power all day yesterday. Literally from, when was it? From like 8 till 7. It was awful. 7 at night. All right, so there you go. You get carbon dioxide and water if you fully oxidize. Now, if there's enough oxygen, to fully oxidize things, we need lots of oxygen. So we need plentiful oxygen. Okay, now if you have what we call insufficient oxygen, and that's not enough oxygen, all right, what we get is this. Instead of carbon dioxide and water forming, we'll get carbon won't be able to grab all of its oxygen. So carbon, you will get some carbon dioxide, but you'll also get some carbon monoxide. And believe it or not, you'll also get some carbon. You pretty well always get water, though. The hydrogen always gets what it wants, but the carbon isn't quick enough to grab all of the oxygen. So this, if you get these things, oh gosh, what's that? My computer's going mad. If you get these two things, this is known, well, these two things particularly. If you get carbon monoxide and carbon, shush, you sausage. All right, this is known as incomplete combustion. So we get incomplete combustion when there is insufficient oxygen. Now, this carbon on its own is just a black solid, and this is often known as, whoopsie daisy, this is often known as soot. Okay, it's blackness. If you put your finger in an exhaust pipe of a car, which you shouldn't do, by the way, but you rub it around in there, it will be sooty. It will be black. A black powder is soot, and that's carbon. It's very pure carbon, by the way. So you can get really nice pure carbon doing it like that. But this guy is called carbon monoxide. Carbon monoxide. Now, carbon monoxide is horrible, and this is poisonous. This is toxic. Okay, and this is why incomplete combustion is bad, a bad thing. Now, when I arrived in Botswana, lots of people used to use paraffin heaters, and there were deaths from carbon monoxide poisoning in those days, because people would just put the paraffin heater on in the winter, and it would build up carbon monoxide, and they'd fall asleep. That's what happens when you get carbon monoxide poisoning. You fall asleep, and then you just don't wake up. It's a weird way of dying. All right. So that's carbon monoxide. So that's a result of incomplete combustion. So that's the first thing alkanes do. They combust. Oh, I didn't say that, did I? They burn. Now, a fancy way of burning, we say combustion. Okay, we say they combust. All right. It's the same as burning, all right, in oxygen. All right, so this is incomplete combustion. Now, the second thing alkanes do, this is number two. Number one was combustion. I'll pretend I've written it up here. Combustion. Number two, and we use them as fuels. Number two, they undergo what we call, I don't know what I was going to write there. What was I going to write? I have no idea. They undergo what we call substitution reactions. All right, with chlorine. The one that's on our course is this. A substitution with chlorine. And now, look, it looks complicated, but it's not. Okay, so here we go. We've got methane, and we react it with chlorine, and we get this thing, chloromethane, and HCl. That's it. Okay. Now, what's happening here? Well, let's have a look. We have a CH4 molecule, and we have a chlorine molecule. Okay. And literally, what happens is the chlorine, the hydrogen goes to the chlorine, and the chlorine goes back on. All right, to the where the hydrogen was. So we get this. Simple as this. The chlorine, I'm going to draw it in a different color. Chlorine goes on, and the hydrogen comes off, and it meets up with the other chlorine. Let me change the color of that. There we are. It's this color, HCl. And that's it. Now, it's like in football. All right, one player goes off, and then another player comes on. Well, that's called a substitution in football. Same here. The chlorine goes into the molecule, and the hydrogen comes out of the molecule. And we get this guy. All right. And this guy, well, what does it look like? It looks like, to me, it looks like kind of methane. So believe it or not, this thing over here is called methane. And this thing here is called methane as well. That's weird, isn't that? But there's a chlorine on it, so we call this one chloromethane. Are we all good? Are we all good so far? Am I not boring you too much? So far, so good. Excellent. Nice one. Excellent. Well done. All right. Now, believe it or not, I can get, this is called chloromethane. Now, I can put another chlorine on it if I wanted to. Okay. And I get this. I get 2 chlorines on it. All right. And if I put 2 chlorines on it, well, it's still, believe it or not, it's still called methane because it kind of looks like a methane. Now there's chlorines on it, so it's called chloromethane again, but it's obviously not the same as this one. But since there's 2 chlorines on it, we call it di. This is called dichloromethane. And if I wanted to go one further, I can. Oopsie daisy. Let me get rid of that. All right. And I'm going to put 3 on this one. There's 1, 2, 3. And what's this one called? Well, this one's called methane. It's 3 on there, sorry, so it's chloromethane. And there's 3 on there, so this is called trichloromethane. Now, the reason I got to this side, this is a colorless liquid. All right. I find this stuff really interesting. This is a colorless liquid. Trichloromethane is a colorless liquid. Okay. And we use it, believe it or not, to wash clothing. We use this to wash clothing. Let me put that in a funny thingy there. Now, this is, I don't know if I don't know how much you like nerdy stuff, but I like nerdy stuff like this. Now, it's used to wash clothing. Is it water though? Is it water? And obviously, the answer is no. It's not water. But we use it for cleaning. So does anyone know what type of cleaning this is? I'll give you 5 seconds to answer. What type of cleaning do we use this for? It's not water. No one knows? Thumbs down if you want me to just give you the answer. Okay, so is it water? No. What's water? Water is wet, isn't it? Yeah? So this thing is not water, so it's dry. Okay? It's crazy but true. Does anyone know where we're going with this? Water's wet, trichloromethane is dry. This is This is dry cleaning fluid. This is what they wash your clothes in if you take them to the dry cleaners, because your clothes aren't washed with water; they're washed with dry cleaning fluid. All right, which is this stuff. Okay. Now this stuff, why do we use it? Well, it's covalent, by the way. So obviously, it's a covalent compound, and because it's covalent, it dissolves things like grease. Dissolves grease and horrible things. How do you spell grease? It's double E, isn't it? I think. Oh God, I'm awful. Is it an A there? Oh, my spelling's awful, isn't it? I'm going to pretend there's an A there because I think there's an A there. All right, it dissolves grease really well. Oh, that looks awful as well. Oh, I was going to put an A, wasn't I? Right, get rid of that and go back to the proper spelling. Grease. Yeah, that looks better. It dissolves grease, so it's dry cleaning fluid. So that's pretty well what alkanes do. Whoopsie daisy. So let's have a look at alkenes now. So the next thing we're looking at is alkenes. And don't forget, this is only an introduction to organic. That's all we've got time for really today. But if you want, we'll continue next week. It's up to you guys. Right, so now let's have a look at alkenes. Okay, now the first alkene, to have a double bond between carbon atoms, you can't start off at 1 carbon atom. You've got to start off at 2. So the first one is this. Okay, now the next one is 3. 1, 2, 3. Now I can put the double bond there. 1, 2, 3. Or I can put the double bond here. Now, believe it or not, the recording's going to stop in a second. Don't worry, I'll start another recording. But believe it or not, we can have double bond there or the double bond there. Okay. Now